concepts. Explain how the processor and the memory are connected with a neat block diagram. This is for 8 marks. Operation of a computer. Here processor fetches information, data or program from input devices, that is keyboard, mouse, joystick, microphone, web camera, scanner, and stores it into the memory. Before the program is being executed by the processor, this program and data must be stored into the memory. Once these program and data are stored into the memory, yes, processor has to fetch the program. That is, program means set of instructions, data means operand, right? So processor has to fetch the instructions one by one by sending the address of the instruction and by sending the address of the data. And so this operation, that is arithmetic and logic operation, will be performed by the arithmetic and logic unit. This ALU is what? It's part of CPU, that is a central processing unit, that is processor, right? And ALU performs the operation and the final result will be sent to output devices, that is webcam, microphone, printer, headphone, right, monitor, speaker. And this entire operation is controlled by the control unit. How does it control the operation? By generating the timing signal. Means what? If processor wants to store some data into the memory, then control unit has to send the right signal. Okay, when control unit sends right signal, then only processor can store data or instruction into the memory. If processor wants to fetch data from the memory or instruction from the memory, then control unit has to send read signal to the memory. When control unit sends read signal, then only processor can fetch data or instruction from the memory. How an instruction gets executed? Add lock A comma R0. Here lock A is what? Name given to the memory location. R0 is processor registers. Here say for example lock A is equal to 25, R0 is equal to 15. This instruction, that is add lock A comma R0 instruction, performs addition operation. Means what? 25 plus R0 is what? 15, 40, and the final result will be stored in R0 register, that is processor register. This instruction adds the operand. Data is also called as operand, one and the same. This instruction adds the operand or data at memory location lock A, that is what is the data here, 25, to the operand in the processor register, that is 15, and places the final sum into register R0, that is 40 is the answer, will be stored in R0. The original content of lock A are preserved. What was the original content? 25. That is still 25 only after executing this instruction. Whereas those of R0, that is previous value of R0 was 15. Now it becomes 40, are overwritten. Here processor fetches the instruction from the memory. Yes, and processor also fetches operand lock A from the memory, that is 25 in our example, and performs the addition operation. 25 plus 15 is what? 14. So this 40, 25 plus 15 is 40. The final result will be stored in processor register R0. So now add instruction. So who performs addition operation? Arithmetic and logic unit of the computer, right? It performs addition operation. Load and add instruction. Load lock A comma R1. Here this load instruction just transfers the content of lock A, that is for example 25 in our example, 25, and transfers the contents of 25 lock A, that is 25, into R1 register. Now R1, the previous value of R1 will be overwritten and lock A is preserved here. This instruction transfers the content of memory location lock A into processor register R1. Now we will take two instructions, load and add. So lock A is what? 25. This 25 is transferred to R1. R1 is equal to 25. Add R1 comma R0. So R1 is equal to 25 and R0 is, for example, R0 is equal to 15. Okay, I'm just taking example. Lock A is 25, R0 is equal to 15. Now what am I doing? I'm performing addition operation. 25 plus 15 is what? 40. The final result will be stored in R0 register, right? And this instruction adds the contents of register R1 and R0 and places the sum into R0. Note that this destroys the former contents of R1, that is register processor register R1, as well as those of R0, right? Whereas the original content of lock A, that is 25 in our example, are that is 25 is preserved. Yeah, okay. How transfers between memory and processor start? Transfers between the processor and memory are started by sending the address of the memory location to be accessed to the memory unit and issuing the appropriate control signals. That is what read and write signals. The data are then transferred to or from the memory. So let me take an example diagram. Connection between the processor and memory. Yes, here first we'll see this is what memory unit. This is processor unit, and processor unit has memory address register (MER), memory address register. MDR is memory data register. Control unit. PC is program control. Okay, this is general purpose register or not. Processor registers or general purpose registers. ALU, that's arithmetic and logic unit, and this is program control done, and IR is what? Instruction register. Yes, now here for in this example we are considering R0 is equal to 15. Fine, and we have two instructions: load lock a comma R1, add R1 comma R0. As I said, each and every instruction will have an address. If that instruction has an address, then only processor can fetch these instructions from the memory. Right now, in our example, what is the address of this instruction? Load instruction 100. Address of add instruction is what? 101. And address of lock A, this is what? Memory location. With respect to memory location is what? 25. What is the address? 103. What is the data? 25. So it's just a lock is what? It's just name given to the memory location, because it's very difficult to remember the address, right? That is why we are using lock A here. Okay, it's just a name given to the memory location. Now it performs addition operation. How exactly this instruction gets executed, we'll see that now. So now PC is what? Program control holds the address of next instruction to be executed. PC holds the address of next instruction to be executed. So what is the next instruction? First instruction itself is the next instruction, that is 100. PC is equal to 100. This instruction, that is this address, is transferred to the MER, that is memory address register. Now this address 100 should be sent to memory, but we cannot directly say, processor cannot directly send this 100 to memory, because control unit has to wait for the control unit to send read signal. Now once control unit sends read signal to the memory, then memory address register, that is data address, that is 100, is transferred to memory. So now what is the instruction here? Load lock a comma R1. This instruction is loaded into MDR. From MDR, this instruction is transferred into IR. Now, once that load instruction, load lock a comma R1 is in our IR register, that is instruction register, means what? It is ready to be decoded. While while the processor is decoding this instruction, first instruction load, gets incremented. PC is incremented to next address. Okay, while the processor is being fetching what is it? Is that decoding the first instruction, PC gets incremented. That is, PC is pointing to will be pointing to the next address or memory location 101. Now PC is equal to 101. Now again that 101 PC one will is transferred to MER. Again control unit sends the read signal. Now MER is what is it? Will fetch the sends the address, and this instruction add R1 comma R0 gets stored into MDR register. From MDR, this instruction is transferred to IR. Now we have both the instruction. Output of this IR is given to control unit. Now what happens now? Now ALU has now this ALU has both the what is it? Only one data now, R0 data, right? So means what? This decoded when I say decoding, right? When these two instructions are present in IR register, right? Means what? It is ready to be decoded. Decoded means what? Type to check the type of operation. Say for example here, what is the operation? Load operation. Here second, what is this operation? Add operation. Means what? Add operation means what? ALU will come into picture, right? So what are the operands now? R0 15. It is given as one input to the ALU, but one more input is stored in the memory again. Now only instructions are fetched by the processor, but now processor has to fetch data 25 from the memory. Now again MER sends the address of data, that is operand 25. That what is the address 103. So MER is equal to 103. Now uh, now again it cannot directly send the address to fetch this data, right? Now control unit has to send read signal. So once control unit sends read signal, MER sends 103. Now this data 25 is stored into MDR register. Now MDR, now ALU has both the data. This output of MDR is given as input to ALU. ALU is equal, that's MDR is equal to 25, R0 is equal to 15. 25 plus 15 is 40. That is the final result, and final result gets stored into R0 register. So ALU stores this final result into R0 register, right? So now if for example I'll write one more instruction here. For example, load log b, load R0 comma log b. What will happen now? That R0, what is the content of R0? Final result 40 gets stored into memory location log b. Means what, I'm storing the final result 40 into the memory, right? So control unit has to send write signal. Now control unit has to send write signal, then only processor can store the final result 40 into the memory. Now MAR, that is memory address register, holds the address of the final result, that is 40. Okay, and MDR holds the data, that is final result. Okay, 25. So now MDR is equal to 40, MAR is equal to address. Means what? For example, address of the final result is say for example 105. 105. Okay, so this MER is equal to 105 address, MDR is equal to 40. So it sends the address to this when only when control unit sends write signal. Now that data final result 40 gets stored into the memory, in which address 105. Okay, in address. Then so this is how it works. And say we'll discuss one more point here: interrupt and interrupt service routine. Now processor is performing some what is a normal execution. While processor is executing the program, if external interrupt occurs, okay, if you suddenly press power button, now I'm taking class now, if I suddenly press power button, press and hold power button, that what is that, it will it's an interruption. Okay, it's an interruption. So means what, when you press power button, it will be interrupted, and it has to processor execute the interrupt service routine program, that is interrupt service routine. Interrupt service routine means program. For example, I'm taking class, you are watching my video now. If suddenly if your parents enters your room, means what, it's an interrupt, right? And they ask you to stop watching the video, my video, and then they'll assign some task to go to market to get some vegetables, right? So you'll have to stop this. That's what if, when your parents enters the class, that is what enters into your room, that is interruption, interrupts, right? When you stop this class, okay, what you'll do, you'll just pause it, and then you'll go attend the what is it, you'll go do the task assigned by your parents, right? So we call it as interrupt service routine. Processor is what is it, stops the current execution when I press power button, and it performs shutdown program. The system will be shut down. That is what we call interrupt service routine program. The now while processor is executing interrupt service program, it stores the contents. Okay, it stores the contents of all these registers into memory. Then it will execute the interrupt service routine program. Once it executes the interrupt service routine program, again it'll again what will happen, if once it finishes that program, again it has to come back, right? It has to execute this program, previous program. So now that whatever the content that are stored into the memory will be restored. When I say restored, it will go to respective registers. Those contents will go to respective registers. Interrupt service, interrupts, and interrupt service routine. Hope it is clear now. Thank you so much for watching. If you have any doubts, please comment below. Thanks a lot.